All right, ladies and gentlemen, welcome once again to one more live streaming here on our channel. We are going through the warm-up week. Very excited to be here with all of you once again on this exciting topic. Today we are going to cover hands-on with Docker with cloud. It's going to be amazing to go over that with you. And if you're new in here, welcome. We are going through a series of live streamings in here on our YouTube channel this week because we're doing a preparation for the intensive cloud training that's coming up next week. All right. And by the way, if you guys are in here, please let me know in the chat room where you're connected right now, because I've seen in the next past few days that there are a lot of folks from all over the world, and mainly here in the US, a lot of folks from different cities and states. So please let me know where you're connected from right now. And in case you're new in here, please consider registering for free on the intensive cloud training. It's going to happen next week. This is just a preparation that we're doing for the intensive cloud training, where we're going to be implementing in a fully hands-on way, a hands-on project based on a real-world scenario. And it's going to be exciting, right? Those days during the warm-up live streams that we're doing here are just like the foundational, content that you're going to need to use during the intensive cloud training. So if you're in here and then it's still not registered, please go there. The link is going to be on the description of this video, and also my team is there right now on the chat room. They're gonna put the link in there so that you can register right away. Okay, and also if you want, please go ahead and share this YouTube link with somebody that somebody from your team, maybe a colleague that that would like to learn more about multi-cloud and DevOps technologies, because I know that this content is going to be very useful for them. Okay, so with that, let's get started. Let me share my screen. And just a quick recap, we are in the warm-up week for the intensive cloud training, as I told you. And on Monday, if you didn't have a chance to watch the live streaming where we discuss on the toolkit of the multi-cloud and DevOps professional, very nice content. Go there and watch it after this one. It's going to be available in our YouTube channel. You can go there and watch it. And on Tuesday, yesterday, we basically covered hands-on with Terraform and AWS. I basically showed you how you could provision an environment on AWS in a fully automated way with just a few commands, right? It was pretty exciting. And today, we are going to be covering a hands-on with Docker on cloud, okay? You're going to learn more about Docker and how it works, and we're going to do a hands-on with that in a few minutes. And then tomorrow, Thursday at 7 p.m. Eastern Time, we are going to do a hands-on with Kubernetes, okay? And then we're going to deploy a Kubernetes cluster. We're going to discuss about the architecture, and you're going to see hands-on with that as well. It's going to be amazing. And then on Friday, finally, we're going to wrap up the series of live streams in here for the warm-up week with a little bit more of hands-on with Terraform, but now we're going to cover Google Cloud as well, okay? And then maybe you're asking, hey, John, but why you are covering those technologies, right? That's a good question. That's the main reason is next week, as I told you, we're going to get started on the intensive cloud training. And then most of those technologies we are going to be using during the hands-on project based in a real-world scenario that we are going to implement together, right? So we're going to be implementing a multi-cloud architecture using Terraform, and the application is going to be deployed inside of a Kubernetes cluster using a container. So that's why it is so important that you have this foundational knowledge beforehand so that you get ready and feel more prepared for next week, okay? So today, basically, we are going to discuss a little bit more on Docker, right? I'm gonna explain you what Docker is if you're new to that. But before doing it, if you have any questions during the hands-on or anytime, just go ahead and ask that on the chat room, because my team members are there. They're going to take your questions that I can focus on the content, okay? So that's just heads up that I want to give you. And as I told you, it's not possible to move forward without knowing what is Docker, right? So basically, if you're new to Docker, just say on the chat now, hey, I'm new to Docker. Just say that you're new, so that I know that you're just getting started. But Docker is very popular nowadays because it is an open source platform for building, deploying, and managing containerized applications, okay? And the main reason that Docker became so popular is because more and more the companies are adopting modern application architectures such as a microservices architecture, right? Traditionally, the way that the companies use it to deploy software would be using a monolithic architecture, which basically means that all the software or the application functionalities, features, and all of that would be like in a single big package. With the microservices architecture, a given application is now divided in multiple small pieces, small packages that are interconnected with each other. Thinking about an e-commerce application, for example, imagine an e-commerce application. On that application, there are many different features. There are features for product catalogs so that the customers can look at the products. There are features for the cart so that the customer can go there, put some item inside of the cart, and finally purchase that given product, right? And many other features. And then in a monolithic architecture, all those features are actually part of the same deploy, okay? When it comes to microservices architecture, this is different because each feature, like I just mentioned, the cart, the product catalog, and many others are going to actually be a smaller piece and divided into a smaller pieces, smaller services, which are the microservices, right? So, and in order to allow those architectures to work fine, there are new technologies that have been utilized so that the companies can make it happen. And one of them was actually the container. And then with the container, you can deploy individual microservices in the format of a container. And anytime that a developer needs to change a given application, they can make a change on that given microservice that's going to be represented by a container, for example, right? So that is just an overview between monolithic versus microservice architectures that you understand a little bit more about that, okay? But in addition to that, Docker helps the companies to actually pack the application files, the application libraries, and all the files required to run a given application in a very portable way, extremely light, and it also ends with that problem that it works on my machine and it doesn't work in the production environment, for example, because you now have just a single unit that you can deploy anywhere, and then it's totally isolated and independent from each other, right? Which is so cool. Okay, so here is one example of a containerized application where you can see that this could be the representation of a web server, and inside of that you could have the software running this web server or this web application, and inside of that server or that container you would have the libraries and the dependencies to make that application to run, right? But you see that there is no operating system required inside of the container, so that's why it makes the container so light. We're going to discuss a little bit more on this architecture shortly as well. But a few use cases, as I just mentioned to you, more and more you're going to see that the applications are becoming modern. The companies are looking to modernize the applications and make them modern, right? And then Docker is going to help the companies to do it, and of course the companies are going to look for IT professionals with those skill sets to help them to implement that, right? The container helps, and when it comes to the modernization from a traditional to a microservices application, it will also, given that the applications are going to be kind of divided into a smaller pieces, so it basically means that if a container fails, within a given microservice, for example, only part of that application will be unavailable, right? Not the whole application is going to be down. And the new deploys, for example, new features, changes in given services from or features from given applications are now not going to affect the components services from a different feature that the developer will not touch, right? So that is the beauty of using Docker, and that's why you need to understand that. And the other thing is, with Docker, you're going to see that we're going to create a Docker image shortly, and the Docker image is just basically a file or a way that we have to pack the application files with the libraries and everything that is required to run the application. And we create the Docker images using the definition files that you're going to see right now, and then you're going to create a new Docker file from scratch. And Docker, of course, is going to help you and the companies to run the applications anywhere, right? So it basically needs to have the Docker runtime engine available so that the application can run. And how Docker is going to help you and your career, right? So learning Docker is the first step to moving to the next level, which is Kubernetes, right? A containers orchestrator. You're going to learn more about that as we go through this warm-up week. But basically, if you want to apply to those jobs that are related to multi-cloud and DevOps technologies, you're going to see that Docker is going to be there for sure. And the other thing is modern applications make use of microservices architecture. So if you want to, for example, work in big companies, big tech companies that are using microservices architectures, for example, and you want to be among the best and the highest paid, that's something that you also need to consider, right? Using Docker for those scenarios. And the other one is that there are other container runtimes, of course, okay? Docker is a type of a container runtime, but Docker is the most popular one. Usually when you go to the job descriptions, you're going to see that Docker is going to be the Docker is going to be the container technology that you're going to see on the top list for sure. And we like to say that Terraform is like the evolution of the manual infrastructure tasks, whereas Docker is the evolution on how we deploy the applications, right? In a fully, I would say portable way, okay? So that is how Docker is gonna help you on your career. So basically, if you want to be among the best, right? The ones that have a really good grasp of the multi-cloud and DevOps technologies, you need to understand Docker. So that's the bottom line. And then just real quick in here on how, what is the difference between a virtual machine and a container before we go to the hands-on so that you can understand. Usually, if you look at the companies today, most of the companies that are still running traditional applications, right, not modern cloud applications, are still running those applications in virtual machines. And how the virtual machine usually works, right? So that's nothing is new in here. So usually you have a virtual machine that runs, first of all, needs to have a physical server, physical hardware, and on top of the physical hardware, you would need to have the hypervisor, which allows the physical server to be virtualized, right? It basically does a bridge between the hardware and the software to allow the virtual machines to CPU, memory, storage, network, and more. And then on top of that, you have the virtual machine, which is basically where you have the operating system. And then on top of that, you have the application that is deployed using, the libraries and the dependencies that are needed, right? So that is how the virtual machine works. Now, looking at a quick comparison on how Docker or a container like Docker would work, it's like this, right? So first of all, the operating system is not going to be part of a container, right? So the operating system, the kernel itself, is going to be outside of the container. And then inside of the container, you're going to have, basically some libraries and all of that. But before that, on top of the operating system, you're going to have the container runtime, the container engine. So it's going to be Docker, in that case, the container runtime that's going to allow us to provision new containers, and then the container engine is going to be the one that's going to do the bridge and the communication with the operating system, allocating CPU, memory, storage, network, and others to the container itself, right? And then finally, we have the container. And the container is going to have only the application libraries, right? Only the application files, the application libraries, and the dependencies as well, okay? So that's going to be how a container would work in comparison to a virtual machine. Mainly here, as you can see, a container doesn't have the full operating system running inside of it. So that's why it makes the container so light and portable, because you don't need to carry all the the whole operating system kernel inside of the container itself, right? So it's gonna actually be outside. So a few items in here to help us to compare. So each virtual machine has the application, as I mentioned, the operating system, the kernel, the libraries, and the dependencies. It's going to be higher resources utilization, right? Because you have the operating system inside of the virtual machine. Same thing for the disk, because you need to have the operating system files in the disk as well. And then usually it's boot up in minutes, because it needs to go through the process of booting up the operating system, initializing the drivers and all of that. Now, when it comes to container, the container has the application files, right, to run the application, the libraries, and the dependencies, and then it's going to carry only a small portion of the needed kernel to run those components, right? And because of that, it is going to be use a lower amount of disk space, all right, because it doesn't need to have the operating system inside of itself, right? And then it's gonna boot up in just a few seconds, because the container doesn't need to handle all the operating system boot up process that usually happens with a virtual machine. Okay, so with that, you see that the virtual machines and the containers are different from each other, because the containers are going to allow the companies to deploy the applications going forward in a much faster and a much more cost-effective way. Okay, so that's why you see more and more the companies modernizing their applications to use containers, and you see more and more the companies are using the virtual machines only for the applications that cannot be modernized, right? So maybe some legacy application or some very, very high intensive workload application that it is still a monolith that cannot be modernized at that time. So that's why you should consider learning more and more about Docker, so that you can be among the best and the best page on this multi-cloud and DevOps market. All right. So now what we're going to do is we're going to have a hands-on. And on this hands-on, I want you to imagine the following scenario, okay? Imagine that you recently joined a company, and on this company, you had a request from your management. Somebody from your management wanted to ask you if you could do a POC, a proof of concept, of an application that you use it to run in a virtual machine, and they wanted to see if that can be actually modernized and run on top of containers, right? And then their ask was to validate the process and deploy that application on Google Cloud, so that they could see if the application would run fine. And then they gave you this task, okay? So in order for you to fulfill this task, first of all, we would need to do a few things. And that's exactly what I'm going to share right now. But before that, let me know, guys, are you enjoying the power of Docker? Give me a thumbs up on this video so that I can see. Let me drink a little bit of water. Give me a thumbs up if you're enjoying the process, and if you're ready to go to the hands-on part, just give me a yes on the chat, okay? So coming back in here, as I told you, that was the requirement. So we need to do a POC, and we need to provision a application that uses it to run in a virtual machine. We need to convert that to run on top of a container. And for doing that, we are going to need to do a few things. And first of all, we're going to use the VS Code for that activity. And what we need to do is we will need to create a new Docker file, okay? So that is usually the first step that you need to do when you deploy a Docker containerized application, okay? We will create a Docker file with the specification of the image that is going to be used to provision a container and provision our application inside of this container, okay? And then, of course, we will need to have the application files, which on this example is going to be a Python application. We're going to use this application as an example for our POC. And then also we do it, what we're going to do is we're going to basically use those files, the Docker file and the application files, to create the Docker image, okay? And the Docker image, as I told you, is just a pack which will have the application files, the libraries, and everything that is required to run a given application inside of a container. And in order for us to create the image, we will need to run a few operations, okay? First of all, we need to run the docker build command, and the docker build command is gonna create the image. And then once the image is created, we are going to push that image to a container registry on Google Cloud. And the container registry is just like a repository where you can store your Docker images. Once we have that, we are going to use the Docker image that we just pushed to the container registry to deploy our application. And for that, we're going to use the Cloud Run, which is a service that allows us to deploy applications using Docker containers without managing the infrastructure, okay? It is completely serverless service from Google Cloud. All right, so that's gonna be our mission right now. You excited? So let me know. Click on the like button if you're excited to do it. We're going to jump to that right now, okay? So what we're going to do, guys, we're going to use the VS Code. So I'm opening up my VS Code in here, and then if you don't have the VS Code yet, you just need to go there and watch the first live streaming that we did, which happened on Monday. And you're going to be able to get the instructions to install that. Very simple. You can just go on Google, download VS Code, and then you can use that. And if you are there on the live too, you know that we have created a folder here on our desktop to store the warm-up week files. Okay, I'm gonna open that folder right now. Open folder, and that's gonna be on the desktop, and then that's the folder, Cloud Warm-up. All right, so as you can see, I have the folder in here, and then we have created a subfolder inside of this one in here for the live 2. And what we're going to do right now is we're going to create a new folder, a folder for the live 3, okay? So I'm gonna basically come in here, and I'm gonna create a new folder right here. It's gonna be the live 3 Docker Cloud, just to keep the things organized. All right, so as you can see, the folder is already in there. Okay, so then inside of this folder, what we are going to do is I'm gonna get the application files from a zip file that I have in here on my computer. That's gonna be the zip file with the POC application that we need to deploy, right? And let me get this file in here real quick. I'm getting that. So hands-on. Okay, so that's gonna be inside of this hands-on folder, and that should be here. All right. Bear with me, guys. I'm just copying to our VS Code. All right, so give me just 1 second. I'm almost there. All right, so if we look at this, it should be already in there. Yeah, okay, so that's good. All right, so if we expand it here, there you go. So this is the folder that has the application files, okay? The application files from the POC application that we are going to use, all right? And as I told you, the first step that we need to do now is we need to create a new Docker file so that we can start putting inside of this Docker file the definition to Docker create the image. Okay, so in order for us to create this Docker file, let's right click on the app folder and click on new file. And the Docker file is going to be Docker file. So that's going to be the file name. Okay, and then inside of the Docker file now, we are going to basically put the configuration that we would like to use to have our Docker image created. Okay, and then all of this configuration inside of this Docker file, the way that I get the information to put inside of it, I look at the documentation and I grab everything from there. Okay, so if you go to the toolkit, live, the toolkit of the multi-cloud and DevOps professional, I've shared with you the links for the documentation of each one of the technologies that we're going to share during this week. Okay, it is there. You can download and keep it with you because that's going to be useful. And I'm going to use those documentations right now. Okay, but first of all, what we need to do in here inside of the Docker file is we need to specify the base image that we would like to use here for our image. So in our case, we are going to use the base image, which is the Python one. Okay, so the base image on Docker is basically, like the name suggests, is the base image that's going to contain some of the applications, tools, files, libraries that we would like to use in our final Docker image. In our case, we are going to basically use the Python base image, and this base image is coming from the Docker Hub, which is a repository of images that you can use for free. And this image is going to be used because my application uses Python, right? So I can just go ahead and use Python as a base image because it's going to have all the Python, everything already configured to run a Python application. Okay, so if you're curious about that, the Docker Hub is a website, is a free website that you can just go there and explore a little bit more, right? So I'm gonna go there quickly so that you can see hub.docker.com, and then once you come in here, you can come in and explore, and then you're going to see all the base images, right? So if you search for Python, this is the base image that I'm going to use, the Python base image, all right? And then here inside of it, you have all the documentation on how to use this image. And you're going to see that I'm going to do something very similar to this instruction because as I told you, you need to know how you can use the documentation to work with cloud, right? So that you can get the information from the proper places, okay? So that's just a quick note on that. So coming back to our VS Code. So now that we have our base image, we are going to basically start preparing the file so that the file, the image can be created according to the instructions on the file. So the next instruction here is going to be copying the files, the application files to inside of our Docker image, okay? And the first file that we're going to copy is the requirements.txt. So this file has the Python libraries that the application that we're going to deploy using Docker is going to need, right? So this is the library that is going to be needed by the application, Flask. That's going to be only the only one application needed at this time. So we are going to basically start typing this, and then we're going to use the copy instruction dot, and then the file name requirements.txt, and then we're going to ask Docker to copy this file to this location, okay? It's going to be requirement slash app slash requirements.txt. Okay, so this is the location of the file on my current directory, and then this is the location that I would like Docker to copy my file when creating the image, right? So inside of the image, during the creation process, Docker is going to copy this file on this location. Okay, so that's how you should see it. And then next, we're going to define the work directory, the working directory of our application using the work dir. And then next, we're going to install the Python libraries required by the application to run, right? So we're going to use the run instruction, and we're going to basically call the pip command, which is a Python library installer, right? So that you can use to install Python packages. Pip install, no cache. I'm gonna just avoid cache here, and then -r, and then the requirements.txt file. Okay, so what it means is basically when the Docker is going to create the image, it's gonna go ahead and run this command inside of the container to install the required libraries in order to application, in order for the application to run. Okay, so that is how it's gonna work. And then we're going to copy the other application files to the container, okay, to our image, which is gonna be the app.py, the Python application file, and then the templates folder. Okay, we're going to use the copy instruction again, and it's gonna copy everything from the local directory, which is the dot, to the /app, the directory that's gonna have all the application files. Next, we're going to basically give a entry point in here so that Docker knows which is gonna be the commands that should be executed to start up the application inside of the container. And then in our case, given that it is a Python application, we're going to use Python. And then finally, the last instruction is going to be the cmd with the application, with the file actually that's going to be responsible for starting up the application. Okay, so in our case, it's going to be the app.py file, which is this file in here. Okay, this file is the file that when executed along with Python, is going to bring up the application inside of the container. Okay, and then with that, doing it, you have your Docker file created, and you have your application files available as well. So the next step is we need to build the image now. It's going to be the process of copying all these application files, installing the libraries, right, and making sure that everything that is in here on the Docker file is executed. Okay, that's gonna be our next step now. So coming back to the presentation, if you look at this, we have already created a Docker file, so now we need to run those steps in here. Okay, and now please pay attention to this. We have a few different ways to do it, okay, meaning running the Docker commands. Okay, we could have Docker installed on your computer. You could go there, install Docker on your laptop, on your Windows, on your MacBook, doesn't matter, okay? Or you could run the Docker command from a place that it has already installed, okay? So in our case, given that we would like to focus the process of creating the image, the Docker image, and running the container without needing to install Docker on our own computer, we are going to take advantage on a very cool, very nice service from Google Cloud, which is the Cloud Shell. The Cloud Shell comes with Docker already pre-installed, okay? And then with Docker in there, we are going to be able to build the image, and finally, after building that image, we are going to test to bring up a container just to see if the application is running fine, and if so, we're going to basically move on and push the application image to the Docker container registry inside of Google Cloud, And then finally, we're going to use that image to provision the application on Google Cloud Run. Okay, so that's going to be the step-by-step process that we're going to do. So now, as I told you, we are not going to install the Docker on our computer. And then because of that, what I'm going to do now is I'm going to zip the files that we have created locally here on our VS Code. Okay, so I'm going to basically put those files in here inside of a zip file. I'm going to zip this app folder. And there you go. It's going to create this app-en file. App-en file. And then we're going to upload this file to Google Cloud Shell. Okay, and then we're going to go from there. So let's go to the Google Cloud Console now. We are on the Google Cloud Console. If you're new to that, this is like the dashboard to Google Cloud. And as I told you, we're going to use the Cloud Shell. So all you need to do is just click in here on Activate Cloud Shell. And the Cloud Shell, if you don't know, it's like having a interactive terminal with like a virtual machine inside of your browser running on Google Cloud. Okay, it's gonna take some time to load, few seconds to load it, but then once it loads, it's gonna help us to execute the Docker commands to build our image and test our application. So it's coming up, there you go. So as you can see now, we have a terminal on our browser, okay? And then this is inside of Google Cloud. And by the way, if you don't have an account on Google Cloud right now, you can create one for free. If you don't want to create one right now, that's fine as well, because next week, when we go to the intensive cloud training, I'm gonna show you how you can create an account for free, okay? So that you can do the hands-on project. But right now, what we're going to do is we're going to upload that zip file to Cloud Shell so that we can execute the Docker operations. Okay? So in order for us to do it, let's come in here on More, click on this 3 dots, Upload, choose Files, and then just pick the zip file that was created. Just click in Upload, and then the zip file is going to be uploaded. If we do a ls, all right, so if we run a ls, it's in there. So you see that the app-en is already in there. So what we need to do now is we need to unzip that. Okay, so it created the app folder for us. And then inside of the app folder, as you can see, we have the app.py file, which is the application file. We have the Docker file that we just created, the requirements file, and then the templates folder, which is a folder that has part of the application files as well, okay? Some front-end templates. So now what we are going to do is we're going to create the Docker image by running the Docker build command, okay? So it's going to be Docker build -t, and then we're going to give a name for this image, which can be app, for example. And we're going to give a tag that's going to be 1.0, and then usually this tag is used to version control your application versions. And then you're going to say dot, because we would like to ask Docker to build the image using the Docker the definitions inside of the Docker file, okay? Hit enter, then it's gonna ask us to authorization, just say authorize. And then it's gonna start the building process of a Docker image. So you see that it starts downloading the base image, the Python image. And then once it downloads that, it's gonna go to the next steps, following what we put inside of the Docker file. So this process is reading the Docker file and doing the activities, right? So you see that it just ran the step 2, the step 3, the step 4, right? Step 5, step 6, and then 5, and then finally step 7. This warning here you can ignore, okay? This is expected. The way that we're running our POC here, it's gonna pop up this warning, but there's no problem. But you see that the image has been successfully created, Okay, so that's the key in here. So now if you wanted to test this image to see if it is working fine, what we can do is run the docker container command, run -- name. You can give a name to the container. That could be app-p, the port that the application is listening on, the port that would like to expose, and then finally the image that we would like to use to create the container. Just hit enter, and then you see that the application container has been created in just a few seconds. Okay, so it means basically now that there is a Docker container running inside of our Cloud Shell. Okay, we just brought up a Docker container inside of our Cloud Shell so that we can see if the container image was created successfully and if everything is working fine before we go ahead and push that image to the container registry and finally deploy to Cloud Run. Okay, so in order for us to see the application running here locally on Cloud Shell, you just come in here on Web Preview, and then you change the port to the port that the application is listening, which is 5000. Change and preview, and if everything works fine, you're going to see that the demo app is going to show up, right? So basically means that the container is running fine. Okay, so if you see this screen, you see that the container that we just created inside of Cloud Shell for testing purposes, that could be inside of your laptop as well, is working fine, is running fine. Okay, now let's just hit a Ctrl+C. Once we hit the Ctrl+C, basically means that the container is going to be stopped. If you refresh in here, you're going to see that it is not running anymore. Now, if you'd like to see all the containers inside of your laptop or even inside of Cloud Shell when you're creating them, you can just run the command docker container ls, and then if it is running, it's going to show up for you. But if you want to see all of them, even the ones that are stopped, you can just add the -- all, and then it's going to show you all the containers, including the ones that are stopped. So you see that the app container that we just created is stopped. And if you would like to start this container, you could run the docker container start and the name of the container. And then if you run the ls again, you see that now the container is up, right? Here it was down, it was exit, meaning that it was off. And here it is up, it is up and running. So if we come back in here and refresh it, you see that the container is now running, but it is still running inside of Cloud Shell. So let's go ahead and stop this container now. We can run the docker container command stop, then the name of the container. And then if you run again the command to check the status, you see that it is not running anymore, which is good. Okay, so basically that's how you do those basic operations inside of a given container, meaning creating a container, starting a container, stopping it, listing, viewing if it is running or not. But again, as I told you, this is still running locally on Cloud Shell, okay? And Cloud Shell is gonna go down once we shut down our browser, so it doesn't, it was not created for you to deploy a container, just for testing purposes. In order for us to deploy a container that can run in a production environment, for example, we need to use a service from Google Cloud, and this service that we're going to use is going to be the Cloud Run. Okay, so just a quick recap. What we have done in here, we have already run the Docker build. So in that case, we have the Docker image created inside of Cloud Shell. Now what we're going to do is we're going to push this image from Cloud Shell to Docker container registry inside of Google Cloud, and then finally deploy the application. That's going to be the process now. Okay, so coming back to Google Cloud, what we can do now is let's just clear the screen a little bit. So what we're going to do is we're going to put a tag on this image that we just created, specifying the location of the container registry on Google Cloud. Okay, then again, I'm getting that from the Google Cloud documentation, okay? It's basically a procedure that you need to do if you want to upload a Docker image, if you want to push a Docker image to a container registry. And the way that you do it is you run the Docker tag, and then you specify the image that you'd like to put a new tag. It's going to be the app 1.0. And then you're going to give the destination tag, which is us.gcr of Google Container Registry.io. So basically, this is the path of the container registry on Google Cloud. And again, I'm getting that from Google Cloud documentation, okay? / and then here we need to give the project IG. So when you create a account on Google Cloud, you're going to get this first project by default, okay? And the project is just a location that you can store your resources on Google Cloud. So we need to give the IG of the project, just copy that. And then finally, / the name of the repository that you would like to use, right? So in our case, I'm going to use the app, which is the same name of our image. All right, so just hit enter. And then when you run the Docker image ls, you're going to see that now we have a new tag on this image with the container registry destination, right? So it basically means that when we upload this image or run the Docker push to upload this image to the container registry, the Docker is going to push this image to this location in here. Okay, so that's, and then this location is the location inside of Google Cloud on the container registry service. Okay, and then the beauty of this is that we can do all of that from Cloud Shell, which is already pre-authenticated, meaning that we don't need to deal with the authentication with Google Cloud and all of that. Very simple. Okay, so that's the beauty of learning Docker with Cloud, not only on your laptop. Okay. All right, so with that, what we're going to do now is we're going to run the Docker push command. Okay, but before doing it, so let's go in here in the container registry service. Just type container registry and then it's going to come up. And then inside of the container registry, you see that we don't have any repositories right now. Okay, and that is expected because we are going to upload that right now. So coming back to the Cloud Shell, we're going to run the Docker command again, and then now we're going to run the push so that we can push that image, upload that image to the container registry, and then we're going to basically give the tag of the image that we would like to push, which is in our case this one in here that we just put a few seconds ago. Just hit enter. Then as you can see, Docker starts pushing the Docker image to the container registry inside of Google Cloud. So now if you come back in here, you see that there is no image at this time, but if you refresh now, there you go, there is an image on the container registry inside of Google Cloud. And then if you click in here, you see that the image, the Docker container image, is already here with a size of around 300 MB, right? So you see how small is a application image when created with Docker. So very, very lightweight, okay? And now what we need to do is coming back to the architectures that you can see. So we have the Docker image now inside of the container registry, as you can see. And now our mission is deploy this application inside of Cloud Run, okay? So that the application can be running inside of a Google Cloud, and anybody with the URL for the application can access that. So let's move forward with that then. So in order for us to do it, what we can do is we could go ahead and search for Cloud Run and do the deployment from there, or we can come in here on these 3 dots, click on these 3 dots, and finally select deploy to Cloud Run. That's how we are going to use. And then you could deploy that to Cloud Run. You could also deploy that to Google Kubernetes Engine and also to Google Compute Engine, right? But the request that we received is to deploy to Cloud Run. So click in deploy to Cloud Run. And then you see that the container image URL is gonna pop up. Okay, it's gonna pre-populate for us. And that's coming from the container registry, as you can see. So now here is a few configurations that we would need to do. The service name is basically the application or the container name that we would like to put inside of Cloud Run. You're going to leave that default for now. And the region, which is in which region, Google Cloud region around the globe, you would like to deploy your application. I'm gonna leave the US Central as a default for now. I'm not going to make any changes on the CPU allocation. And here on authentication, I'm gonna allow the unauthenticated invocations. Okay, I don't need to have authentication at this time. And then here, under container connections and security, I'm gonna make a change in here on the container port. If you remember, the application is listening on the 5000 port, so we're going to make 5000. Okay. Then I'm not going to make any other changes and just click on create. So when you click on create, what's gonna happen is Cloud Run is gonna go there and download the Docker image from container registry. And it's going to use that image to provision a container in a very quick manner, right? So in a few seconds. As you can see, it has already completed. Okay, it's already deployed the application inside of Google Cloud, and then it generates a URL for us. So you see this URL. So let's click on that and see if the application is running fine. And there you go. Now you see that the application is running successfully inside of Google Cloud. Oh my gosh, guys, how cool that can be, deploying an application very quickly. And then if you copy this URL and give to anybody across the globe, they would be able to access the application immediately because it is now running in production. It's now running on Google Cloud. So that is amazing. And you see that we deployed that in just a few seconds now, right? Now imagine the days that you would need to create a virtual machine, take days, and doing all of that. And then now in the container, it takes just a few seconds. So that's why, the companies are looking for the IT professionals with those skill sets, right? And then the ones that have it are among the best and highest paid in this market right now, especially if you have the multi-cloud and DevOps technologies skill sets together, right? Because you see that those two words, they walk together, okay, which is pretty awesome. All right. So now, by the way, if you enjoyed that process, leave me a thumbs up on this video, okay? And give me a awesome on this chat as well so that I can see that you enjoyed this process. So what we have now is the application running on Google Cloud. So we fulfilled the request of doing a POC, right, of converting an application that uses to run in a virtual machine to run inside of a container on Google Cloud. So the request has been fulfilled successfully on this POC. Okay, so great job for staying back and working on that with me. So now what we're going to do is we're going to basically remove this. Coming back to Cloud Run, you can just click in here, select that and click in delete, and it's gonna delete for you very, very easily, very, very quickly. All right, and it's gonna remove the container in a few seconds. There you go. Then if you go back now on the application and you refresh it, you see that's gonna give you an error because the application is no longer running. All right, so very, very simple, guys. So congratulations with that. You have now followed the hands-on process of creating a Docker application from scratch, right? A Docker container running an application from scratch, which is pretty awesome. Now you tell me, did you enjoy this process? Did you see the power of Docker now? So I love doing Docker, so I hope you loved as well. And again, this is just a warm-up live for the intensive cloud training that we're going to do next week, that we're going to implement a hands-on project based in a real-world scenario using those technologies. Okay, so this is just the foundational knowledge that you can get ready for what's coming next week. So if you are not registered yet, you can register for free. The link is on the description. It's going to be on the chat right now. I want to ask my team to put on the chat room as well. Okay, and tomorrow we have another live meeting here, and then that's going to be the time where we are going to cover Kubernetes. Okay, so the most popular container orchestrator is going to be the topic of the tomorrow's live streaming. So tomorrow at 7 p.m. Eastern time, we are going to be back in here to talk about Docker and do a hands-on as well. Okay, and if you have enjoyed this, I would say training, right? It's almost a training on Docker. Please give me a thumbs up and give me a yes on this chat, and you are my guest tomorrow for the Kubernetes Live. It's going to be a pleasure to be here with all of you, okay? It's going to be 7 p.m. Eastern Time. Stay here tomorrow so that we can go together. And again, if you have any questions, I'm going to ask my team to stay back for a few minutes on the chat room to take your questions. Please go ahead and ask them, and I hope to see you tomorrow, okay? Take care, guys. Bye-bye.